Welcome to Introduction to Power System Operation Training, powered by Tonex.com. Introduction to Power System Operation Training course establishes the essential frameworks of age plants, or generators, their control, concepts of economic dispatch, and power flow analysis. This course gives you adequate information about generator elements, an idea of dependability in power framework activity. Through Introduction to Power Framework Activity Training course, Newton-Raphson and Gauss iteration as two distinct answers for the power flow analysis will be talked about. Introduction to Power System Operation Training course basically shows you how the power is created in power plants and what steps are taken so as to convey the produced power to the customers with high dependability. A few control approaches are presented for the generators, keeping in mind the end goal to accomplish stable task of the power framework. This course talks about the cutting-edge control approaches executed for generators to keep up the voltage and recurrence inside the cutoff points. This course centers around the H side, as well as spreads the transmission level by presenting the idea of power flow as a propelled tool to compute the working focuses in the power framework. Through Introduction to Power Framework Task Training course, Newton-Raphson and Gauss iteration as two distinct answers for the power flow analysis will be examined. At last, Introduction to Power Framework Task Training course will quickly present the economic dispatch in power framework, including generator cost capacities considering transmission lines and generator limits. Audience: all individuals who need to understand how the electricity is generated in power plants and how the stable operation is achieved in power systems. Faculty members from academic institutes. Investors and contractors who plan to make investments in this industry. Marketing people who need to know the background of the products they sell. Technicians, operators, and maintenance personnel who are or will be working at power plants or power system generation companies. Managers, accountants, and executives of power system industry. Scientists or non-electrical engineers involved in power system operation related projects. Training objectives: understand the generator models and control. Describe the dynamics of generators in power systems. Understand the concept of stability in power systems. Understand the operation of a generator connected to the system. Recognize the voltage, frequency controllers in generators. Discuss different types of loads connected to the power systems. Describe the concept of voltage stability and frequency droop. Model the dynamics of governor and automatic voltage regulator, AVR. Understand the concept of stability and operation in multi-machine power systems. Explain the step-by-step process of power flow analysis. Understand and explain different solutions for power flow equations. Understand the basics of economic dispatch. Training outline. Power system background. Different power system levels. Synchronous machines, generators. Single machine infinite bus, SMIB, concept. Effective loads. Generator control. Power flow analysis. Economic operation of power systems, economic dispatch. Power system background. History of the power generation. What is a generator? What is a transmission line? Definition of loads. Improvements in modern power plants. Different power system levels. Generation levels, power plants. Transmission levels. Sub-transmission levels. Stations and substations. Distribution level. Synchronous machines, generators. Basic operation principles of synchronous machines. Rotor and stator definition. Field and armature windings. Magnetic flux in the airgap. Voltage generation. Dynamic model of generators. Mechanical dynamics. Swing equation. Single Machine Infinite Bus, SMIB, concept. Maximum Power Transfer in SMIB. Power Angle Stability Criterion. Voltage Stability Criterion. Voltage Collapse. Effect of loads. Constant loads. Constant admittance loads. Constant power loads. Dynamic loads. Power electronic-based loads. Electric vehicle charging. Load restoration techniques. Tap changer transformer. Generator control. Voltage control. Definition of AVR. AVR model. AVR dynamics. Frequency control. Definition of governor. Governor dynamics. Primary frequency control. Secondary frequency control. Multi-area frequency control, ACE concept. Power flow analysis. AC power flow. DC power flow. Solutions for power flow. Gauss iterations, Gauss-Say ideal. Newton-Raphson. Fast decoupled solution. Economic operation of power systems, economic dispatch. Formulation of economic dispatch problem. Classical economic dispatch. Economic dispatch considering generator and line limits. Penalty factors. Hands-on, workshops and group activities. Labs. Workshops. Group activities. Sample workshops and labs for introduction to power system operation training. Simulating transmission lines with MATLAB. Simulation of synchronous machines. Single machine infinite bus example in MATLAB. Demand response simulation and case study. Lab on generator AVR and PSS control. Experiment on frequency control for generators. Voltage control by generators case. Call us today at 1-972-665-9786. Learn more about course audience, objectives, outlines, pricing. Learn more about Introduction to Power System Operation Training. Visit tonex.com for more information.